Today's experiment is the analysis of Alka Seltzer. Alka Seltzer, if you're not familiar with it, it's an old-fashioned hangover cure. Okay, the way Alka Seltzer works, they're little dry tablets that contain aspirin, sodium bicarbonate, or baking soda, and a little citric acid. And you drop them into water. The citric acid dissolves. The acid reacts with the sodium bicarbonate. And it makes a nice solution here. It's a nice buffer solution. So it helps ease an upset stomach if you have a hangover. The aspirin, because it's dissolved in water, is rapidly absorbed. And it's supposed to help with headaches and hangovers. Personally, I think the way it cures the hangover is this stuff tastes horrible. Once you take a taste of this, you stop worrying about your headache. Alright guys, our Alka Seltzer tablet. Again, it's a combination of aspirin, baking soda, and citric acid. Citric acid is a dry white powder. So all three chemicals are smashed together here. What we're trying to do today is figure out what percentage of this tablet is the baking soda. So we'll weigh the tablet so we know how much the tablet weighs. Then we just have to figure out how much of that tablet happens to be the sodium hydrogen carbonate. Now, you can't very well take little tweezers and pluck out the grains of baking soda. So we're going to do something that chemists do all the time. We're going to take the stuff we're looking for, we're going to change it into an entirely different chemical that we can measure. So we're going to take this baking soda, react it with hydrochloric acid, gives us water, carbon dioxide, and sodium chloride. Well, that carbon dioxide is a gas. So we're going to collect the carbon dioxide gas, measure how much CO2 we get. Once we know how much carbon dioxide we got, we know how much sodium bicarbonate we started with. Okay, so what we're directly measuring today, we're measuring the volume, the temperature, and the pressure of this carbon dioxide gas. We'll know the pressure of the gas, and we're going to measure that pressure in units of atmospheres. We'll know the volume of the gas. We'll initially measure it in milliliters, but we'll have to convert it into liters. We'll know the temperature of that gas in Kelvin. We'll measure it in degrees Celsius, but convert to Kelvin. So we'll know the pressure, the volume, and the temperature of that CO2. And then we'll use the ideal gas law, which is PV equals nRT. N, of course, stands for moles. So if we rearrange this, we can solve it for N. We say that the moles of CO2 that we measure, remember that's what we're measuring, is the CO2. The moles of CO2 that we measure would be the partial pressure of the CO2 times the volume all over R, the gas constant, and T, the temperature in Kelvin. R here is the gas constant. Okay, here's our ideal gas law. PV equals nRT. N, of course, stands for moles. Since we're measuring the pressure, the volume, and the temperature of the CO2, we can rearrange this and solve it for the moles of carbon dioxide. We use the partial pressure of the CO2, the volume that we measured, the temperature. R is the gas constant, 0.0821 atmospheres, liters per mole Kelvin. So this is the number that you're going to be sticking in here for R. Okay, we use our ideal gas law to find moles of CO2. Well, if you look at the stoichiometry of the reaction, 1 mole of CO2 is equivalent to 1 mole of the sodium hydrogen carbonate. So moles of CO2, moles of the sodium hydrogen carbonate, the same number. Once you know the moles of sodium hydrogen carbonate, you can then use the molar mass of the sodium hydrogen carbonate to figure out how many grams of sodium hydrogen carbonate or grams of baking soda were in the tablet. Okay, how are we going to measure that carbon dioxide that's coming from our Alka Seltzer tablet? Oh, we're not going to use the whole tablet. We're just going to break off a small piece. So we will weigh this Alka Seltzer tablet, then we'll decompose it to give the CO2 gas. How do we measure that CO2 gas? With this apparatus. A simple U-shaped tube with a liquid in it. It's water. We put a little green food coloring in there. And you can see if I raise this up, the water level goes up. If I lower it, it goes down. This is called a leveling bulb. So you start this procedure with your Alka Seltzer in a tube. That's our reaction chamber. You take hydrochloric acid, you add it to this small tube, plop it in there, you put this tubing together, and we'll explain the little leveling bulb here in just a moment. Now, when both ends of the system are open, got a little hole here, so this is open to the atmosphere, this is open to the atmosphere. I have the same pressure here, I have the same pressure here, and the same pressure here. These two liquids are at the same level. Now, as soon as I put this stopper in, pressure here is different than the pressure here, so the two water levels are probably off a little bit. Before you take a reading, you simply adjust it so the two levels are the same. This would be our initial volume in the burette right here. Okay, we took the initial reading. Now, of course, we had to make sure the two liquid levels were the same. What that does is it assures us that the pressure on this side of the system is the same as the pressure here. Now, to run the reaction, we simply let this hydrochloric acid come in contact with the Alka Seltzer. And I hope you can see the water in the burette is dropping like a rock here. That's because, of course, the Alka Seltzer generates that carbon dioxide gas, which applies a pressure and pushes that down. So, still going down there. So you can see the pressure in this end of the system right now, the closed end of the system, is higher than the pressure here. That's what's pushing that liquid down. Now, I can't really take this reading as is. I have to level it first. Again, when I level it, that's adjusting this pressure to be the same as this pressure. Watch how much that water level changes as I go to level it. Do you see how it makes quite a bit of difference with the leveling bulb? Changes the volume by several milliliters.
And that would be my final volume right there.